Hello children, this is class 12 Applied Mathematics, Chapter 2 Algebra, Assertion and Reasoning Questions. So, we are aware that in your Applied Maths question paper, first 20 MCQs will be available in section A. In that, question number 19 and 20 will be the Assertion and Reasoning questions. In that, two labeled statements will be there. One is assertion, another is reasoning. In assertion part, very often most of the people consider this assertion as a statement and the reason as a defending statement or the cause for that. So, to get rid of such confusion, a regular practice of assertion and reasoning is required. This is the purpose of this video. So, how to solve this? First thing, read the question at least twice. Don't be in a hurry. Don't think that it is just one more question. Don't be hurry. Just read the question twice and understand each statement well. Evaluate the given statement independently. In the previous video also I told first solve the reason, then go for the assertion. Evaluate both the statement. Read well both the statement individually and understand whether it is true or false. Don't assume things. Just like that, once you read the reason or just you read the assertion, don't assume anything. Think twice and come to the conclusion. The very shortcut for this is why I am telling you to check the reason first. If the reason is false, among these four statements, the third statement, only in this third statement, we have the reason false. So, if the reason is false, automatically we'll go and opt option C. If the assertion is false also, it is easy. Once the reason is false, then go for assertion. If the assertion is false, we go for option D. Suppose both are true, assertion is true and reason is also true, then we analyze the relation between this A and R. Depend on that. If one is explaining the other, go for option A. If there is no connection between A and R, go for option B. This is the procedure. You can solve this A and R questions. Any tips or tricks? Yes, there is a tip. That is a cute tip. Yes, reason. The reason should have a connection with the assertion. The reason should connect to the assertion. Or the reason is used in the assertion. The reason should be used in the assertion. Or the reason should tell about the assertion. Or the reason will be explaining the assertion. So these are the four tips you can relate the assertion with the reason. In this chapter 2 algebra, we have matrices, determinants and solving these simultaneous equations. In this chapter particularly, among all the 8 chapters, in this algebraic chapter, matrices and determinants, what are all the properties there? Read the properties, make note of the properties well, because the properties, the statements which you are learning, standard rules which you are learning will be given in the reason. The application will be given in the assertion. So it is important we should be thorough with the reasons. Okay. See in this question number 1, assertion A is if A and B are symmetric matrices. You are very well aware of what is symmetric matrix. Symmetric matrix means when you transpose a matrix, the transposed matrix will be same as the given matrix. That is what symmetric matrix. Then BA minus 2AB is not symmetric. So A and B are symmetric. Then BA minus 2AB is not symmetric. The reason is If A and B are symmetric matrices, then BA minus 2AB is not skew symmetric. Now you can compare the assertion statement as well the reason statement. Both the statements are looking alike. The only difference in these two statements is here it is mentioned not a symmetric matrix. Here it is mentioned not a skew symmetric matrix. What is skew symmetric? If the A transpose is equal to A, it is symmetric. If the A transpose is equal to minus A, it is skew symmetric. This is the difference between symmetric and skew symmetric. Now we will analyze the statement. I told you first check the reason. So, what is the reason? A and B are symmetric. Yes, A and B are symmetric. BA minus 2AB is not skew symmetric. So, just expand BA minus 2AB. Find the transpose. Dash means transpose. Either you write the symbol T or put dash. Both are same. When you transpose it, individual transpose will be written BA the transpose minus 2AB the whole transpose. When you open the bracket, reversal law will be used. So A dash B dash minus B dash A dash. 2 times the B dash A dash. When you simplify this, you will get AB minus 2BA. This is 2. 2 should come here. Okay. So AB minus 2BA. If it is AB minus 2AB, you can simplify. But in matrices, AB and BA are not same. We cannot say it will be same. It may be same or it may not be same. So we cannot simplify that. You are getting AB minus 2BA. Suppose if you take minus common, because to show that skew symmetric we need a minus symbol common, right? If you take the minus common, the statement becomes 2 times BA minus AB. If it is 1 time BA minus 2AB, it is similar what it is mentioned here. But it's not like that. It is 2BA minus AB. So, it is not as mentioned in the given statement. Not statement. You should be little more careful whenever not is mentioned. So, it is true statement. The reason is true. Once the reason is true, we have to go and check the assertion. Assertion also same way you expand. Wherever whole dash is there, put individual dash. Wherever multiplication whole dash is there, reversal law should be used. So when you check that, assertion is also true. So both A and R are true, but A is talking about symmetric matrix, B is talking about skew symmetric matrix. Here, A assertion is not used by the reason. Assertion is not connected with the reason. There is no connection between symmetric and skew symmetric. Both are different kind, right? So it is not connecting, it is not explaining, it is not using the reason, it is not telling about the reason is not telling about the assertion. So it is not used here. So it is not the proper explanation of the assertion. The reason is not the proper explanation of the assertion. So we go for option B. Option B is second subdivision. Okay, like this you can decide the answer. Question 2. Assertion. Value of x for which the matrix a 3 by 3 matrix is given is singular is minus 5. So what they are telling in this assertion statement is, if this matrix is singular, then the value of x is minus 5. This is what they mean. What is singular? What is singular matrix? Any matrix whose determinant value is 0 is singular. Okay. If you find the determinant value, it should be equal to 0. Then the reason, the square matrix A of order n, where The determinant of ASSERTION equal to determinant a power n minus 1. This is a standard rule, right? Reason is a standard rule. So, reason is true. Reason is a standard statement. It's a rule, it's a formula, so it is true. We go for assertion. Once reason is true, we should go for the remaining three options. For that, we have to check the assertion. Assertion, it is mentioned if it is a singular matrix. So we keep it as a singular matrix by keeping the determinant value equal to 0. Just expand it through the first row. You are getting the value x 2x plus 8 plus 2, that is 2x plus 10 equal to 0. So you are getting x value minus 5. So assertion is also true. Both assertion and reason are the true statements. Now we will check whether they have connectivity between these two. Reason is telling about a standard rule, but this assertion is not using the standard rule. The assertion is not using the standard rule. It is just finding the determinant value. This is some other property. So there is no connectivity between the given assertion and the reason. So we can conclude that this A and R are true, but R is not the correct explanation of the given assertion. So option B is the right answer. Question 3. Assertion A. If each of the matrices of same order are symmetric, then their sum is also a symmetric matrix. If each of the matrices of same order are symmetric, then their sum is also a symmetric matrix. Suppose you are taking 2, 3 matrices. Each one is a symmetric matrix. Means if you add them up, the result will also be symmetric. This is the statement given under assertion. Now the reason is if each of the matrices of same order are not symmetric, then their sum is a symmetric matrix. If the given matrix are not symmetric, here given matrix are symmetric, here given matrix are not symmetric. So we cannot judge anything with this reason. So we will just take some example and take. Here I have taken 3 matrices. If it is symmetric, generally we will check the reason. This time I am checking the assertion. It is symmetric means A dash will be A, B dash will be B, C dash will be C. So I am just, they talk about the sum of the symmetric matrices. So first I will find the sum of the matrix, then its transpose. So A plus B plus C the whole transpose. So A transpose plus B transpose plus C transpose. Already we told these are the symmetric matrices. So A dash will be A, B dash will be B, C dash will be C. So the transpose of sum of 3 matrices are equal to the same sum of the 3 matrices. So this is not possible if the given matrices are not symmetric. If these are not symmetric, this cannot be possible, right? A plus B plus C, the whole transpose will be A dash plus B dash plus C dash only. It will not again become A plus B plus C. So the reason is not true. The reason is not true. If the reason is not true, straight away we will go and opt the option C. Question number 4. Assertion for a square matrix A 4, 5, 2, 8. A into ASSERTION equal to the identity matrix with the diagonal of 22. Okay. Reason. This is, as we said in the first step, we have to individually evaluate the statement. Now go for the reason. For a square matrix A into ASSERTION equal to determinant into I. This is a standard rule, right? The matrix into its adjacent ASSERTION is equal to determinant value into identity matrix. So this is a standard rule, so we know the reason is true. Now we'll check it with the given matrix in the assertion part. First find the determinant of this A. 4 8s are 32, minus 2 5s are 10, 22. 22 into identity matrix is 22, 0, 0, 22. Yes, the assertion also correct. And assertion is true, reason is also true. The reason The assertion is using this reason. This formula it is using. So used. So assertion and reason both are true. And R is the correct explanation of the assertion. So we go for option A. Assertion A. If A is a symmetric matrix, then A cube is also symmetric. This is the assertion. Reason. If A is a symmetric matrix, then A dash power n equal to A power n the whole dash. That means if A is a symmetric matrix, the transpose raised to the power n or the matrix raised to the power n then transposed. Both will get the same value. We will check. The reason is a standard rule. So it is true. Now we will check it with the assertion. To clarify the assertion, we will take the symmetric. It is given A is a symmetric matrix. So take A equal to A dash because it is a symmetric matrix. Then A cube means A cube the whole dash will be A dash whole power 3. That means A dash will again become A. A transpose is A because it is given symmetric. Again it become A into A into A cube. So it is also symmetric. The given assertion is true and the assertion used the rule which is given in the reason. So we go for option A. Question 7. Assertion. If A is a skew symmetric matrix, then A cube is also a skew symmetric matrix. The same way, the reason is if A is a symmetric matrix, here it is given skew symmetric. It is given skew symmetric. Here it is given symmetric. If A is a symmetric matrix, then A dash whole power n equal to A power n the whole dash. Same like the previous question. The reason is a standard statement. So it is true. Now again we check with the same method. A equal to A dash because it is given symmetric matrix. Sorry, because it is given symmetric matrix. If it is symmetric matrix, if it is Q, no, we will be take it as negative. Then A cube the whole dash or A dash the whole cube means A dash into A dash into A dash. If A dash is minus A, if it is symmetric, it is like last time we can prove like a question number 6. Now it is skew symmetric means it is minus A. So this is, if this is correct, you have to write minus A here. Okay. So first statement A equal to A dash is symmetric. Now if you consider it as skew symmetric, this is correct. A as it is skew symmetric, I have taken minus A. So minus A into minus A into minus A is minus A the whole cube. But here they told it is also skew symmetric. It is also skew symmetric. So the assertion is not true. If A is skew symmetric, then A cube is also skew symmetric. Yes, A cube means A cube the whole dash is equal to A dash whole power cube. Yes, it is correct only. It is getting minus A only. If A cube is equal to minus A the whole cube, minus A cube only, no? Minus A, it is correct only. So assertion is also true. Assertion is also true. Both A and true. A is also true because it is particularly given cube. That is why it remains as minus. Minus means Q symmetric. Both are true. But the thing is, it is talking about a particular Q symmetric matrix. The reason is talking about symmetric matrix. So we cannot use this symmetric matrix rule to the skew symmetric matrix. Here particularly this statement is true, but it is not using the rule given in the reason. So we will go with option B. We will go with option B. A and R are true, but R is not the explanation. R assertion is not using the reason. So we go with option B. Question 8. If A and B are square matrices of same order, then A plus B the whole square is not equal to A square plus 2AB plus B square. It is the assertion. Just like an algebraic identity, it is expanded, but we should remember that A and B are square matrices. Generally in matrices, AB is different from BA. We should remember that. In reason it is mentioned that if A is a square matrix, generally A comma B are square matrices. Generally AB need not be equal to BA. AB need not be equal to BA. So the reason is a standard rule. It is true. Then A plus B the whole square, just multiply it. A to A into A square, A into B, AB, B into A, BA. So AB and BA is not same. So you cannot combine and write it as 2AB. So it is not equal. So assertion is also true. Both are explaining the same matter where AB is not equal to BA. So A is the R is the correct explanation of assertion A. So we go for option A. Question 9. Assertion. If A equal to alpha, beta, gamma minus alpha, a 2 by 2 matrix such that A square equal to I, then 1 plus alpha square plus beta gamma equal to 0. When do you get such a statement? If you find the determinant value of this matrix only, you will get such statement. Okay. Now the reason. If A equal to alpha, beta, gamma and minus alpha is such that A square equal to I, then this is equal to 0. It is not 1 plus alpha square, 1 equal to. It is 1 equal to alpha square plus beta gamma. Okay, just take A square equal to I, and take A into A, first row multiplied by first column, second row multiplied by first column. Then first row multiplied by second column, second row multiplied by second column. You simplify this, you will get a matrix like this. They told it is equal to identity. So equal it to identity. Compare the corresponding element. Alpha square plus beta gamma equal to 1. Alpha square plus beta gamma equal to 1. Right? This is what we mentioned here. Alpha square plus beta gamma equal to 1. So the reason is true. The reason is true. Here they told 1 plus alpha square beta gamma equal to 0. But if you transpose these terms to the right side here, you will get 1 minus alpha square minus beta gamma equal to 0. It will not be plus. It is obviously minus only. So this assertion is false. If the assertion is false, we go for option D. Question 10. A is a square matrix such that A square equal to A. Then I plus A the whole square minus 3A equal to I. Mere calculation. The reason is A into I equal to I into A, which is equal to A. Any matrix multiplied by the identity matrix, you will get the same matrix. So this reason is also a standard rule. So it is true. Now we check the assertion. A square equal to A is given in the assertion. So I plus A the whole square expanded. I square plus 2AI into A square equal to I square is I only, 2A into I. Any matrix into I will be the same matrix, so it becomes 2A. A square equal to A, It is given statement. So you add this 2a plus a is 3a. It is equal to I plus 3a. I plus 3a. So I plus a the whole square is I plus 3a. If you transpose it to this left side, I plus a the whole square minus 3a equal to I. This is what the given assertion. So assertion is also a true statement, and whatever formula is given as a reason, we used it here. So the reason is used in the assertion U. So we go for option A. Both A and R are true, and R is the correct explanation of the assertion. Hope this video will be helpful to you. Just go through it once again to know the standard statements of this matrices. Keep this clue CUTE so that easily you can answer this assertion reasoning questions. All the best for your exam.